The following video presentation will be covering the proper installation procedures for the Panasonic ECOi VRF systems. ECOi Indoor and Outdoor Unit Product Offerings. The Panasonic Air Conditioning Division offers a wide variety of different indoor unit types and different BTU capacities for both the indoor and outdoor units. The outdoor units shown here are all of the different outdoor models manufactured for the U.S. market. All of the Panasonic outdoor units are equipped with DC inverter-driven compressors for increased efficiencies and reliability. The ECOi VRF two-way mini outdoor units referenced as LE models are available in either a 3 or 4.5 ton capacity and operate off of a 208, 230 volt, 60 hertz single phase power supply. The ECOi two-way outdoor units referenced as ME models are available in either a 6, 8, 10, or 12 ton capacity. The models shown here operate off of a 208 or 230 volt, 60 hertz, 3-phase power supply. The ECOi two-way outdoor units shown here are also available in the same tonnages, but with these models requiring a 460 volt, 60 hertz, 3-phase power supply. The model numbers shown here are for the 460 volt models as indicated by the last digit in the model number ending in 4. The ECOi three-way outdoor units referenced as MF models are available in either a 6, 8, 10, or 12 ton capacity and can provide simultaneous heating and cooling. The model numbers shown here operate off of a 208 or 230 volt, 60 hertz, 3-phase power supply. The ECOi three-way outdoor units shown here are also available in the same tonnages, but with these models requiring a 460 volt, 60 hertz, 3-phase power supply. The model numbers shown here are for the 460 volt models as indicated by the last digit in the model number ending in 4. The two-way and three-way outdoor units can also be doubled or tripled together to form a larger BTU capacity refrigerant circuit up to a maximum tonnage of 30 tons. The following slides will be covering the VRF system's installation wiring requirements as it pertains to the power supply wiring, low voltage control wiring, and three-way solenoid box wiring. All of the ECOi indoor units will require a 208 or 230 volt, 60 hertz single-phase power supply connected to the L1 and L2 terminals of the indoor unit along with the ground wire. The low voltage communications wiring installed from the outdoor unit will be connected at the U1 and U2 terminals of all the connected indoor units and must be installed using an 18 gauge 2-conductor stranded and shielded wire. The remote controller wiring is connected to the R1 and R2 terminals of the indoor unit as an 18 gauge 2-conductor stranded and shielded wire. This slide shows where the power supply wiring and low voltage communications wiring is connected to on the 3 ton and 4.5 ton ECOi VRF mini outdoor units. This slide shows where the power supply wiring and low voltage communications wiring is connected to on the 2-way and 3-way 6, 8, 10, and 12 ton outdoor units. The low voltage communications wiring running from the outdoor unit to all of the indoor units must be installed as an 18-gauge 2-conductor stranded and shielded wire. This low-voltage wiring must also be installed in a daisy chain configuration as shown, making sure the shield wire is grounded on one end of this wire. Also make sure this same shield wire is wired together to the next shield wire at each indoor unit. The U1 and U2 wiring is not polarity sensitive. On systems where the outdoor units are piped together, forming one large refrigerant circuit, it will become necessary to link the low voltage wires from each outdoor unit together. An 18-gauge 2-conductor stranded and shielded wire must be connected at terminals 1 and 2 of each connected outdoor unit. This slide shows 3 outdoor units interconnected as one large refrigerant circuit with 2 indoor units along with all of the associated high and low voltage installation wiring. The low voltage communications wiring is a very critical part of the ECOi VRF systems. This communications wiring must be installed only in a daisy chain configuration. This slide illustrates one of the common mistakes where the wiring was starred together at one or more junction points. This type of wiring configuration will cause communication errors to occur and should not be installed as shown. Similar to the wiring being starred together, another low voltage wiring precaution is to not form any loops within the daisy chain wiring as well. This type of wiring configuration will also cause communication errors to occur and should be avoided as well. One way of checking the integrity of the low voltage communication wiring between the outdoor unit and all of the connected indoor units is by conducting a continuity check across terminals U1 and U2 of the indoor unit and terminals 1 and 2 of the outdoor unit. A good wire will show a continuity reading of around 75 ohms or more, with the electrical meter being set to its lowest continuity scale. The term link wiring will be referenced throughout many of the installation manuals. Link wiring is installed when one of the Panasonic centralized control devices are being utilized to control all of the indoor units of multiple refrigerant circuits. This link wiring connects to the low voltage communication wiring terminals of different refrigerant circuits with an 18-gauge 2-conductor stranded and shielded wire. When the total number of indoor units being controlled exceeds 64, another link wire will have to be installed at the outdoor unit and connected back to the centralized control device. The term group control wiring refers to multiple indoor units being controlled by a single remote controller. A single remote controller can control up to a maximum of 8 indoor units. An 18-gauge 2-conductor stranded and shielded wire must be daisy chained from the single remote controller to all of the indoor units to be controlled on the R1 and R2 terminals of each indoor unit as shown. All indoor units will be governed by the same mode of operation, set point, and fan speed when wired together as a group. All of the ECOi VRF indoor units will come shipped with a 5-conductor wiring harness already attached to the 3-way connector of the indoor unit's printed circuit board. This wiring harness is only utilized when the installed outdoor unit is a 3-way model. On the 3-way system, this wiring harness will connect to a 5-foot gray cable, which then connects back to the relay box portion of the 3-way solenoid box kits. Keep in mind this gray cable being supplied with the 3-way solenoid kit is only 5 feet in length, so the relay box must be installed within 5 feet of the indoor unit's electrical control compartment. This is a picture of a single-port 3-way solenoid box kit. These kits come with the 5-foot gray cable, which connects back to the indoor unit, the relay box, the solenoid box, and all the necessary mounting hardware. The three-way solenoid box must always be installed right side up in a horizontal position within the refrigerant piping network as shown here. The metal mounting bracket will connect to the top of the solenoid box. A field-supplied 18-gauge 5-conductor thermostat wire will need to be installed from terminals 1 through 5 on the relay box to terminals 1 through 5 on the three-way solenoid box. In addition to this, the solenoid box will require a 208 or 230 volt single-phase power supply. This slide shows all the power and wiring connections required for the single-port three-way solenoid box. Shown here are one of the newer 4-port three-way multi-solenoid boxes. Unlike the single-port boxes, these are designed to be more centrally located to supply multiple indoor units from one centralized location. These multi-port solenoid boxes are also fed off of one 208 or 230 volt single-phase circuit and can reduce the amount of refrigerant tubing between the indoor units and the solenoid box when centrally located. In different parts of the country which are prone to high winds and heavy snowfall, the wind and snow baffles are recommended for the outdoor unit. These snow and wind baffles offer protection from excessive snow and ice buildup on top of the condenser fan air outlet, in addition to protecting the condenser coil. Always make sure the outdoor units are elevated above the average forecasted snowfall within these snowy regions. Also, the outdoor unit should always be securely fastened to the mounting support system using the bolt holes on the bottom of the frame. The ECOi VRF outdoor units can also be installed into an indoor environment such as a penthouse or mechanical room where local building codes permit this type of installation. Once installed in this type of application, adequate makeup air must be supplied, calculated based on the number of outdoor units being installed. The discharge air off of each outdoor unit must also be ducted to the outside environment. The outdoor units being heat pumps will produce condensate water during defrosting cycles. This condensate water will have to be diverted to a floor drain or pumped utilizing a condensate pump if auxiliary drain pans are being utilized. The following slides will cover refrigerant tubing, pressure testing, and evacuation of these systems. The proper initial design and layout for the ECOi VRF systems is completed utilizing the Panasonic Pack Design software. Once the indoor and outdoor units equipment details are entered, preferably with the projected refrigerant tubing lengths, a refrigerant tubing diagram can then be created. The refrigerant tubing diagram will be the roadmap for correctly piping the refrigerant tubing from the outdoor unit to all of the connected indoor units. The proper refrigerant tubing diameters will be listed using letter codes as shown. These refrigerant tubing diameters must be followed to ensure the proper refrigerant flow to all of the connected indoor units. If this original refrigerant tubing layout changes due to the addition or removal of indoor units and/or changes in the original projected tubing lengths, these changes must be updated back into the Pack Design software refrigerant tubing diagram to ensure the refrigerant tubing diameters have not been changed. This slide shows a single three-way outdoor unit where the suction, discharge, and liquid line are piped into a three-way single-port solenoid box. Dependent on the remote controller mode of operation setting, the three-way solenoid box will either provide high-pressured hot gas for heating or low-pressured suction gas for cooling to the indoor unit through the energizing of different solenoid valves. The 6-ton through 12-ton two-way and three-way VRF three-phase outdoor units can be doubled and tripled together in order to achieve larger system capacities. Anytime the outdoor units are doubled or tripled together, the 1/4-inch oil equalization line from each outdoor unit must be interconnected with all of the interconnected outdoor units. The outdoor unit and indoor unit refrigerant tubing is connected by utilizing a series of the Panasonic distribution joint kits as determined by the Panasonic Pack Design software. These distribution joint kits are installed at different points within the refrigerant tubing to ensure that the proper flow of refrigerant is being supplied to all of the connected indoor units. This slide shows how the Panasonic distribution joints will be installed when the outdoor units are doubled or tripled together. This is a picture of the inlet side and outlet side of the refrigerant tubing connections for the three-way multi-port solenoid box. The different style three-way single and multi-port solenoid boxes are selected based on the total indoor unit BTU capacity requirements. The refrigerant tubing can also be continued through the three-way multi-port solenoid box on the opposite outlet end, which will be brazed and capped shut from the factory. Never flow any nitrogen through any of the solenoid boxes during the brazing process, as this can cause damage to the internal solenoid valves. This slide shows a side view of a three-way multi-port solenoid box where the indoor unit refrigerant tubing would be connected. This solenoid box must be installed right side up in a horizontal position as shown. A small amount of dry nitrogen must be flowing through the refrigerant tubing during the brazing process, with the exception of the three-way solenoid boxes. This slide shows the difference and benefits of flowing nitrogen through the refrigerant tubing during the brazing process. The inner copper wall will become extremely oxidized without the use of nitrogen. Panasonic does not require any additional refrigerant components within the refrigerant tubing during installation, such as suction or liquid line dryers, sight glasses, mufflers, oil traps, or any solenoid-operated shutoff valves. Refrigerant isolation ball-type shutoff valves with refrigerant gauge port access can be installed within the refrigerant tubing at the installer's discretion. This type of shutoff valve can offer isolation of the three-way solenoid boxes, indoor units, and outdoor units depending on the installation location within the refrigerant tubing. Care should be exercised during installation as to not overheat these valves while brazing the connections. The refrigerant tubing connections on all the indoor units will require flaring of the copper. Always remount the inner wall of the copper tubing using a copper reaming tool prior to forming the flare. Make sure the finished flare does not show any cracks, uneven thicknesses, or is inclined more to one side than the other. Always use the factory flare nuts which are provided with the indoor units. The outdoor unit service valve connections will be both flare and braze connections depending on the model being installed. When brazing in the connections, protect the service valves with a wet rag or heat sink paste to keep from overheating these valves. The refrigerant access gauge ports on these systems are not the standard 1/4-inch gauge hose connections. In order to pressure test, evacuate, and charge the system, a 5/16" by 1/4-inch gauge port adapter will be required. Several different manufacturers produce these adapters as shown here with the different part numbers. Prior to releasing any of the R410A refrigerant charge contained within the outdoor unit, a nitrogen leak test of all the flared and brazed connections must be completed. The final stage of nitrogen testing should be pressure tested up to 450 psig and held for a minimum period of 24 hours. Once the system is held at dry nitrogen pressure of 450 psig for a minimum of 24 hours, an evacuation of the system can now be performed. The refrigerant tubing must be pulled down to a minimum vacuum level of 500 microns. An accurate micron gauge will be needed to measure the level of vacuum achieved. If the system fails to pull down or will not hold a 500 micron vacuum or less, another pressure test of the refrigerant tubing will be needed. Do not forget to evacuate the oil equalization line on installations where the outdoor units are doubled or tripled together. Next, we will discuss some of the Panasonic central control devices available. This is the Panasonic System Controller. This is a central control device that is capable of controlling up to a maximum of 64 indoor units. This controller requires a 12-volt DC power supply, which is supplied from the indoor unit's main printed circuit board at the T10 connection of this board. The T10 wiring connector will be packaged with the system controller. The T10 connector is only 6 to 8 inches long and will need to be extended with an 18 2-conductor stranded shielded wire and connected back to the 12-volt DC terminals of the system controller. A second 18-gauge 2-conductor stranded and shielded wire will need to be ran from the U1 and U2 terminals of the indoor unit back to the U1 and U2 terminals of the system controller. This is the Panasonic Intelligent Controller. This is a central control device which is capable of controlling up to 128 indoor units as a standalone device, or 256 units when used in conjunction with the Panasonic communications adapter. The intelligent controller is powered with a 24-volt AC power supply. Both the intelligent controller and the communications adapters are equipped with 2 sets of low voltage wiring links, labeled as Link 1 and Link 2. Each wiring link is capable of controlling up to a maximum of 64 indoor units. These wiring links will connect from the outdoor units' low voltage terminals 1 and 2 or U1 and U2 with an 18-gauge 2-conductor stranded shielded wire. The number of these wires needed from the outdoor unit back to the intelligent controller will be based on the total number of indoor units installed. For example, if there are 3 different refrigerant circuits with a total number of 80 indoor units connected between all 3 separate outdoor units, known as the refrigerant circuits, then 2 separate sets of 18-gauge 2-conductor stranded shielded wires will need to be installed. The U1 and U2 wiring is not polarity sensitive. This is the Panasonic communications adapter. When needed, this device becomes an extension of the intelligent controller to enable communication with an additional 128 indoor units. The communications adapter will accept either 115 volt AC or 208 or 230 volt AC power supply. The low voltage wiring links 1 and 2 on the communications adapter will be wired from the outdoor unit back to the communications adapter using an 18-gauge 2-conductor stranded shielded wire. Each link on the communications adapter is capable of communicating with a maximum of 64 indoor units. In addition to the central control devices, Panasonic also offers a wide variety of both Wi-Fi and built-in management control devices as well. This concludes our ECOi installation video. Please contact the Panasonic Technical Support Division should you have any questions pertaining to the information presented within this video. Thank you for watching.